Have you ever wondered how companies like ElevenLabs build AI voice generators that can handle thousands of users without expensive servers? In this video, we're going to build a complete AI text-to-speech SaaS application from scratch using React, Firebase, and the Cloudflare ecosystem. And the best part is that you can deploy it almost completely for free. We'll start by creating a modern front end with React and Firebase authentication. Then we'll write our Cloudflare Worker backend, configure all the required environment variables, and connect our application to Cloudflare D1 for storing users, projects, and job data. Next, we'll set up Cloudflare Queues to process long-running text-to-speech requests in the background. Configure Cloudflare AI Gateway to securely manage all AI API calls and create an R2 bucket to store generated audio files. You'll also learn how to connect everything together from user authentication and database integration to queue consumers and audio downloads. Finally, we'll deploy the entire application to Cloudflare and see how to run a professional AI SaaS product with minimal infrastructure costs. So, if you want to learn how to build scalable AI applications using modern serverless technologies, let's get started. Build a professional AI text to speech SaaS for free with Cloudflare. Imagine building a production ready AI text to speech platform like ElevenLabs or OpenAI without paying for expensive servers. In this project, we'll create a modern AI SaaS application using React, Firebase, and the Cloudflare ecosystem, taking advantage of Cloudflare's generous free tier. Our front end uses React 19, Vite, TypeScript, Tailwind CSS, and ChatCN UI to deliver a premium user experience. The interface includes authentication, dashboards, job history, audio playback, analytics, and user settings. For authentication, we'll use Firebase authentication with Google sign-in and email login. Firebase securely manages users, while Cloudflare Workers verify Firebase JWT tokens directly at the edge, eliminating the need for traditional backend servers. The backend runs entirely on Cloudflare Workers with the Hono framework. Instead of maintaining virtual machines or containers, Cloudflare Workers execute our code globally across hundreds of edge locations, providing low latency and excellent scalability. To manage application data, we'll use Cloudflare D1, a serverless SQL database built on SQLite. D1 stores user accounts, projects, text to speech jobs, usage statistics, billing information, and processing status. Since D1 is fully integrated with Workers, we can perform database operations with minimal configuration and no server management. When users generate speech, the workflow is simple and scalable. The React front end sends the request to the Worker API. The backend creates a new job entry in D1 and pushes the task into Cloudflare Queues. Queues allow us to process long-running AI jobs asynchronously, ensuring that the user interface remains fast and responsive. The queue consumer then communicates with external AI providers such as ElevenLabs or Replicate. To improve security, monitoring, caching, and analytics, all AI requests pass through Cloudflare AI Gateway. AI Gateway provides centralized control over model usage and API traffic. Once the AI model generates the audio file, the worker uploads it to Cloudflare R2. R2 is Cloudflare's object storage service and is perfect for storing MP3, WAV, and generated assets. Unlike many cloud providers, R2 offers zero egress fees, making it ideal for media-heavy AI applications. The complete processing pipeline looks like this. Front-end Cloudflare Worker, T1, Database, Cloudflare Queue, AI Gateway, ElevenLabs or Replicate, Cloudflare R2, User Download. One of the biggest advantages of this architecture is cost. Thanks to Cloudflare's free tier, developers can deploy a professional-grade SaaS application with almost zero infrastructure cost during the early stages. The Cloudflare free ecosystem includes Cloudflare Workers for serverless backend APIs, Cloudflare D1 for SQL database storage, Cloudflare Queues for background processing, Cloudflare R2 for file and audio storage, Cloudflare AI Gateway for AI request management, Cloudflare Pages for front-end hosting, global CDN and SSL certificates included by default. Deployment is straightforward. The React frontend can be deployed to Cloudflare Pages with a single GitHub integration. The backend worker is deployed using Wrangler CLI. D1 databases, queues, and R2 buckets are created using simple commands. And Cloudflare automatically connects all services together by combining React, Firebase, Cloudflare Workers, D1, Queues, R2, and AI Gateway. We can build a scalable AI text-to-speech platform that supports thousands of users while keeping infrastructure costs close to zero. This architecture provides everything needed for a modern SaaS product: authentication, database storage, file hosting, background jobs, AI integration, global deployment, analytics, and enterprise grade performance, all without managing servers. Now that we've provided the prompt for creating our AI text to speech web application, the AI has started generating the entire project structure, including the user interface and all the required pages such as the login page, dashboard, job history page, and audio generation page. As you can see, the application follows a modern SaaS design similar to platforms like OpenAI and Vercel. But building the UI is only one part of the process. Behind the scenes, multiple Cloudflare services work together to handle authentication, database operations, AI processing, and file storage. For a better understanding of how everything connects, let's take a look at the architecture diagram of our project. Our React frontend communicates with Firebase authentication, allowing users to securely log in using Google or email. Every request is then sent to Cloudflare Workers, where our backend APIs are running. The worker verifies the user's token, stores the job information inside the D1 database, and pushes the text to speech request into Cloudflare Queues for background processing. The queue consumer then sends the request through Cloudflare AI Gateway to external AI providers such as ElevenLabs. Once the audio is generated, it is stored inside Cloudflare R2 and becomes available for playback and download from the dashboard. In the next section, we'll dive deeper into each component, configure all the required services, set up environment variables, and deploy the complete application to Cloudflare. Now that we've generated the initial version of our AI text-to-speech application, we can already see that the AI has created the main UI components and pages, including the login screen, dashboard, job management page, and audio generation interface. However, as expected with any large project, there are still a few errors and configuration issues that need to be fixed before the application is fully functional. Don't worry, this is a normal part of the development process. To solve these problems quickly, we'll use anti-gravity to analyze the codebase, identify the issues, and automatically suggest the necessary fixes. Whether it's missing dependencies, incorrect configurations, API errors, or type mismatches, we'll go through each problem step by step. Once the fixes are complete, we'll continue configuring Cloudflare Workers, D1, Queues, AI Gateway, and R2 storage to get our text-to-speech SaaS running smoothly. Let's jump in and start debugging the project. Great! Our UI is now ready. The AI has successfully generated all the major pages, including the login page, dashboard, text-to-speech generator, and job history section. At first glance, everything looks polished and professional. The next step is to test the authentication flow by trying to log into the application. Let's click the Sign In button and see what happens. Go to Firebase, give project name. I had given ElevenLabs once the project created, we need to set up authentication. So in this example, setting up only Google authentication, I had selected that configure the project details. Setup is done. Once it is done, you need to register the app. For that, give the app name. Once it is done, it give all the Firebase config details like a key auth, domain project ID, etc. The details we need to paste in our application. So we need to copy this as expected. We are immediately running into an error. But don't worry, this isn't a problem with the UI itself. The issue is that we haven't configured Firebase yet. The front end already contains all the authentication logic, but it still needs to be connected to an actual Firebase project. To fix this, we'll head over to the Firebase console and create a new project. Once the project is ready, we'll enable the authentication providers that our application supports, such as Google Sign-in and email/password authentication. After that, we'll copy the Firebase configuration values, including the API key, project ID, authentication domain, storage bucket, and app ID. These values will then be added to our environment variables so that the React application can communicate with Firebase. On the backend side, we'll also need to configure Firebase token verification inside our Cloudflare worker. Since workers run on the edge and don't support the full Firebase admin SDK, we'll use Firebase's public keys to validate user tokens securely. Once the Firebase configuration is complete, we'll restart the application and test the login flow again. At that point, users will be able to sign in successfully and will be ready to move on to setting up the database, queues, and the AI processing pipeline. Now, it's time to connect our application to Firebase. To do that, we'll open the write single quote firebase.t's write single quote file inside our project and paste the Firebase configuration that we copied from the Firebase console. This configuration contains important information about our project, such as the API key, authentication domain, project ID, storage bucket, and application ID. These values allow our React application to communicate with Firebase services. Next, we'll initialize Firebase and export the authentication instance so that it can be used throughout the application. Since our project uses Google and email sign-in, this step is essential for the login flow to work correctly. After saving the file, we'll install the Firebase package if it hasn't been installed already and restart the development server. Once the application reloads, it should be successfully connected to our Firebase project. With Firebase now configured, we're one step closer to completing our AI text-to-speech platform. In the next section, we'll test the authentication flow and continue setting up the backend services on Cloudflare. Perfect! Now that we've finished configuring Firebase, it's time to redeploy our Cloudflare worker and test the application once again. We'll rebuild and deploy the backend so that the latest environment variables and authentication settings are applied. Once the deployment is complete, let's head back to the application and try logging in. And there we go. The login is now working successfully. Our application is finally able to communicate with Firebase, verify user credentials, and authenticate users correctly. Behind the scenes, the React frontend sends the Firebase ID token to our Cloudflare worker, where the token is validated before granting access to the dashboard and protected pages. This confirms that our authentication flow is working end-to-end. Users can now sign in using their accounts and start using the application. In the next steps, we'll focus on connecting the database, setting up queues, and implementing the text-to-speech generation pipeline. Now that our application is working correctly, the next step is to configure Cloudflare AI Gateway. AI Gateway acts as a central layer between our application and external AI providers, allowing us to monitor requests, apply rate limits, and analyze usage from a single dashboard. To begin, open your Cloudflare dashboard and navigate to the AI Gateway section. Click on Create Gateway and enter a name for your gateway. You can choose any name that matches your project, for example, ElevenLabs Gateway. After creating the gateway, you'll see several configuration options. One of the most important settings is rate limiting. Here, you can define how many requests your application is allowed to send within a specific period. Depending on your expected traffic, you can set the rate limit to whatever value best suits your use case. This helps protect your application from abuse and prevents unexpected API costs. Next, open the Providers tab. Cloudflare supports a wide range of AI providers, including OpenAI, Anthropic, Google, DeepSeek, and many others. Since we're building a text-to-speech application, we'll select ElevenLabs as our provider. Once ElevenLabs is selected, Cloudflare will ask for your ElevenLabs API key. After adding the key, all requests from our Cloudflare worker will be routed through AI Gateway before reaching ElevenLabs. Using AI Gateway provides several advantages. It gives us detailed analytics about every request, including latency, token usage, and error rates. It also makes it easier to switch providers in the future without making major changes to our application code. From this point onward, whenever a user clicks the generate button, the request will travel through our Cloudflare worker, pass through AI Gateway, reach ElevenLabs for voice generation, and finally return the generated audio to our application. Before deploying the application, we need to configure a few environment variables for our Cloudflare worker. Open the Cloudflare dashboard and navigate to Workers Changed No Settings, Variables and Secrets. Here, we can add values such as the Cloudflare account ID, Firebase project ID, AI Gateway URL, and any other configuration required by the application. We'll also need to add the ElevenLabs API key as a secret. If you're using Cloudflare AI Gateway, make sure to open the Providers tab in AI Gateway and add your ElevenLabs API key there as well, so that all requests can be routed through the gateway. Alternatively, many of these settings such as D1 databases, R2 buckets, queues, and environment variables can also be configured directly inside the wrangler.json or wrangler.etoml file. Once everything is configured, redeploy the worker and the application will be ready to authenticate users, process jobs, and generate audio. R2 Object Storage. Select your bucket and open the Settings tab. Scroll down to the Course Policy section and add a new rule. Here, we need to specify the origins that are allowed to access the bucket. For local development, you can add your Vite URL, such as staging URL or prod, and later add your production domain after deploying the front end. Alright, let's test our application and see everything working together in real time. First, I'm going to create a new project and name it Audio Voice. Next, I'll select the voice model, and for this demo, I'm choosing **Drew***. Now let's enter some text. I'll type, "Hello Digital Savvy Zone, how are you? How can I help you?" Everything is set up, so let's click the **generate** button and send the request to our backend. At this point, our application creates a new job, stores it in the database, and sends it to Cloudflare Queues for background processing. The queue consumer then communicates with the AI provider, generates the speech, and stores the audio file in Cloudflare R2. Let's wait a few seconds for the generation to complete. And there it is. The audio has been created successfully. Let's click play and listen to the result. What's really impressive is how quickly we were able to build a fully functional, production-ready AI application. In just a short amount of time, we've created a professional SaaS platform with authentication, databases, background processing, cloud storage, and AI-powered voice generation, all running on modern serverless infrastructure.
How are you?
This shows how powerful today's tools and AI-assisted development workflows have become. With the right architecture and cloud services, building applications that once required entire engineering teams is now possible in just a few hours. And that's it for this video. We've successfully built the user interface for our AI text-to-speech application and explored how all the different components fit together. In the next video, we'll configure Firebase, set up authentication, and continue building the backend infrastructure with Cloudflare. If you found this video helpful and want to follow along as we build this project from start to finish, make sure to subscribe to the channel and turn on notifications so you don't miss any upcoming videos. Also, let me know in the comments what features you'd like to see in this AI SaaS application. Thanks for watching, and I'll see you in the next one.